So for number 60, we're using the first derivative and the second derivative to find out this information. The function y is equal to x plus sine of x onto the first derivative. So the derivative of x is 1 and the derivative of sine is cosine. Notice there's no place where this is undefined, but there are going to be places where the derivative equals 0. Oh, by the way, on this one I meant to say from 0 to 2 pi. Okay, for this one you can subtract 1 from both sides. And then it says, when does cosine equal a negative 1? Well, if you look at the cosine graph from 0 to 2 pi, there's actually one place where it equals negative 1, and that's right in the middle of the graph. And if that's 2 pi, that means that right here is pi. So x equals pi seems to be the only critical value that we find. Then graph it and see if that makes sense. So graph the original problem, x plus sine of x. Change the window to go from 0 to 2 pi. And then I'm going to guess negative 5 to 5 for the y values. And make sure it's in radians, like that. So it seems like there's one place right here where the derivative equals 0, although I couldn't quite see the last part of the graph. So let me change the window to go up a little bit higher. How about to 10? So sure enough, there's one place where the derivative equals 0, it's right there. And I can even double check this theory. Ask the calculator, what's the derivative? And the critical value that we got is pi. So then pi. And it says the derivative equals 0 right there. So where is it increasing and decreasing? So we could use the number line method. We could also use the graph, since the graph seems pretty reasonable. So right here, that's the pi, that's where the derivative equals 0. Then this is increasing, and this is also increasing. So for increasing, that would be from 0 to pi, and also pi to 2 pi. And then we need to take out the pi, because when it hits this point right here, it's flattened out. It's neither increasing or decreasing. So it's increasing from 0 to pi, and actually that's a square bracket, so this should be a square bracket. And then put a round parenthesis to take out the pi. And then the right side from pi to 2 pi. For decreasing, does not apply. There's none. It's not decreasing. And as far as minimums and maximums, this is neither a minimum or a maximum, so we're just going to have to go with the endpoints. This is the lowest point of the graph, and this is the tallest part of the graph. Oh, I didn't draw it very accurately. It's actually at the origin, but that's okay, because now I can just say 0, 0, that's the minimum. 0, 0. And then this is 2 pi. So trace and put 2 pi. And in case I haven't told you this before, what's happening is when I set the window, right here, I put 2 pi. And as soon as I move the cursor, it puts a decimal approximation. And basically that decimal approximation is stopping right here, right before 2 pi. And then when I type in 2 pi, it doesn't know what I'm talking about. So what I need to do is just make this a little bit wider, regraph it, and then I'll be able to substitute the 2 pi. Trace, put in 2 pi. So that's actually 2 pi, 2 pi. So the maximum is at 2 pi, 2 pi. Okay, now we're done with the first derivative. For the second derivative, so take the derivative of the derivative. This will be 0. Derivative of this is going to be negative sine. So the second derivative is equal to negative sine of x. Then set that equal to 0. You could multiply both sides by a negative 1. It will then say, when does sine equal 0? So the sine graph looks like this. It equals 0 when x equals 0, when x equals pi, and when x equals 2 pi. Remember, the second derivative is telling us concavity. So this is concave down, and this is concave up. And if you look at the graph, this is concave down, and this is concave up. So it doesn't have to be as extreme as these, but this is bent down, and then this is bent up. So for concave up, that's going to be from here to here, so that means from pi to 2 pi. And for concave down, that's going to be from here to here, so that will be 0 to pi. I also asked for the asymptotes, but this one has no asymptotes. It's not leveling off horizontally, and there are no vertical lines where it's undefined, so it actually has no asymptotes. So this is all of the information.